So 1.1 is looking at graphs of equations. Two concepts that you guys got to know about are solutions and symmetry. A solution to an equation, solutions to equations are values that make, or values that work, I should say. What does that mean, values that work? Well, let's say we have something like 2x plus 1 equals 9. What is the value that I could plug into x that would work? 4. So that's a solution. Okay, I also want you guys to write down, see, that's the solution right there. I'm just going to point it out. That's a solution to an equation. Write down a solution to functions. Those are x values that make f of x equals 0 true. Okay, so that means like if I plug the x value in, I will end up with a 0. This one, I plugged the 4 in and I got a 9. Okay, but this is an equation. I'm talking about a function. A function would have two variables, one variable being your f, aka the y value, and the other one is the x, the one that you plug into it. Solutions to functions are also known as roots, x-intercepts, zeros, etc. I don't know. I just put etc. because I can't think of another word for it, but I know all these mean the same exact thing. Symmetry, I guess I'm just going to keep this really simple. Excuse the brevity, is a reflection. Why did I say that? Because pretty much when you have symmetry, it looks like you're reflecting. Like, let's say this one right here. If that is the left side of the graph, this would be the right side of the graph. This is symmetry about the y-axis. So I'm going to say sem about y-axis. All right, let's look at another one. Let's do symmetry about the x-axis. Okay, so that would be like this, but then you would also have this right here. Ooh, that does not look like it's the same. Okay, that kind of looks like the same. All right, so this is sem about x-axis. The last one is the weirdest one. It looks like this. Let's see. Oh, I could just do a straight line. Check that out. Okay, you could also have like curvy lines, but this is symmetry about the origin. I'll show you another example of this. Alright, let's continue on with this idea of symmetry. We're going to look at these graphs right here. Quick question, guys, and tell your teammates which of these graphs have symmetry. Alright, that's enough. Stop talking to each other. This is a polynomial function. That's a polynomial function. That's an absolute value function, and that is an exponential function. I don't know if you guys recognize those guys, but this guy does not have symmetry, and neither does that one. This one does. It's kind of obvious, I think. This one has symmetry about the y-axis. This is y-axis symmetry. Now this one right here, this guy is the weird one. That one is symmetrical though. You guys know what symmetry that one is? Origin, the weird one. This is origin symmetry. Okay, let me give you some other things you guys can copy down if you'd like. I know you guys already wrote pictures down, but I just want to slap down a couple other examples. This one is x-axis symmetry. This one's y-axis symmetry. And this one is origin. Now the most important things to take note of are your coordinates. Look at them. What is the difference between these coordinates right here? What is it that is changing? If you look at the x-axis of symmetry, the y values are changing. The x's are the same. This right here, this graph that I have for the x-axis of symmetry is not going to be a function. Why is it not going to be a function? Because if I were to plug in this x value, let's say this x value is a 3, no, a 2. So this is 2 right here. What is the answer? Is it this y or is it this y? I don't know, but because I get 2 answers for one x value, this is not a function. These two are functions though. If I plug in a negative x, I get y. If I plug in a positive x, I get the same y, but I'm plugging in two different x values. And the origin, the thing to note here is that the coordinate signs are just changing. So if they're both negative, then they're both positive. If one's negative, one's positive, then the other one is going to be positive, negative. It's going to switch. All right, so here's a question that relates to symmetry. Does the following function have symmetry with respect to x-axis, y-axis, or origin? Okay, now there's two ways to figure this out. One, let's say you just know what that looks like. That's a quadratic equation, so you know what it looks like. You're thinking about that function, and you're like, oh, well, that's a quadratic, so I'm going to have something that looks like this. Now, if I just had x squared, that would be my graph. But I don't have just x squared, I have this minus 6. Do you guys know what minus 6 does to the graph? Does something to it. Yeah, it brings it down. Now, if ever you have an adding or subtracting, it's going to move the graph left, right, up, or down. Because this is not inside parentheses, the minus 6 moves the graph down 6 spaces. And so we would go down 6 spaces to negative 6, and then you would draw your parabola. And it still has symmetry about the y-axis. There's another way you can test this. If your suspicions were that it has symmetry about the y-axis, what you can do is you can take a number like negative 3 and positive 3, two opposite numbers, and you can plug them in to see if you get the same y value. See, this says if I have a negative 3 and a positive 3, I should get the same y value. Well, let's try it out. I'm going to plug in 3, negative 3, and it gets squared, and I subtract 6. Negative 3 squared is 9, and when I subtract 6 from that, I get 3. Is that right? Yeah, that's right. If I have positive 3 and I square that and subtract 6, positive 3 squared is 9 and I subtract 6, I get the same thing. Both of these get a 3. So because the y values are the same and the x values are opposites, I know that this has symmetry about the y-axis.